Good evening, everyone. This is LadyDragon speaking. It is Tuesday, January 9. It's 9:10 p.m. Well, now we're gonna finish with the last press conference of CES. It's Intel, like I told you before. This is where we're gonna go to, and I'll talk to you after.
Statements in this presentation that refer to future plans or expectations are forward-looking statements. These statements are based on current expectations and involve many risks and uncertainties that could cause actual results to differ materially from those expressed or implied in such statements. For more information on the factors that could cause actual results to differ materially, see our most recent earnings release and SEC filings at www.intc.com.
Please welcome to the stage Jack Wiest, Intel Fellow, Vice President and General Manager, Intel Automotive.
Thank you. Thank you, everyone. Let me just extend a huge thanks to all of you for making it your way over here to the Venetian from the Convention Center or wherever else you may have been to join us for our inaugural Intel Automotive CES keynote. So it's really an amazing time to be in the automotive industry. But I know a lot of you might be thinking, why Intel? What do we have to offer? And why now? Why is this the right time for Intel to help the automotive industry? So our legendary CEO, Andy Grove, once said that market share is gained and lost in times of transition. And this is an industry that is in the midst of a radical transformation. So these are wise words for all of us. Not just for Intel, but for the entire industry. And so, I say this industry is in disruption, but I think if we're truly honest, this is an existential moment for the automotive industry. This industry is going to look completely different by the end of the decade than it does today. And so, it's because there's a perfect storm of 4 different things that are happening. The first is we have the transformation of greater levels of autonomy. The second, re-architecture to software-defined. Third, move to electric vehicles. And fourth, a market disruption, with more new vehicle brands emerging around the world than the industry has seen in a very long time. So in thinking about this disruption of this century-old industry, I couldn't help but think of a different industry that was similarly disrupted with products that have changed our lives forever. And that's the smartphone industry. And lots of books have been written on this topic, but I'd like to share my hypothesis and my perspective on what happened then, and what can we learn from that industry transformation and apply here to the automotive industry today. So most of us feel like we know this history because we lived it. We all had phones like you see there on the left. But as consumers, it felt like overnight, we went to go get a new phone and suddenly all the feature phones were gone. And all you had were smartphones to choose from. And in that transformation, some iconic brands that had been around for a very long time were suddenly gone and irrelevant because they failed to make the pivot. So I think it's important for us to think about, why did this pivot happen when it did? What can we learn from it? And what were the signs that we saw coming? So I assert there are 5 elements necessary for industry transformation. They may not happen overnight. They might be spread across a lot of years. But when that 5th and final element is in place, that's what breaks an industry wide open and transforms it for a long time to come. So let's take a closer look at the history of smartphones. So first of the 5 elements, a major milestone, the BlackBerry 850 for those that remember, it had Intel, leading node silicon inside that device. So that was cool, but it didn't really transform the industry. Then we had the first iPhone, and I think the most important part of that device was a user experience paradigm change in the form of touch. But that didn't really break it open because, there was no app store. It was Edge, so some of us geeks bought it, but that was about it. So that pivot still hadn't happened yet. We needed more milestones. The third was the creation of an application developer ecosystem. The fourth was infrastructure-based, which was the rollout of 4G, so that the device was actually useful over something other than Wi-Fi. But that fifth and final element for transformation was a market-based disruption. Consider that over half of the world's 4G towers are deployed in China. In a lot of countries in Southeast Asia, your phone and your phone number is like your social security number. They're cashless societies where your phone is everything. So that showed a path to the rest of the world of what those devices could be and how they would transform our lives forever. So that fifth and final element was that market disruption that started in Asia and spread all across the rest of the world. So where are we in our automotive industry journey? Well, in 2012, we saw the first of two, leading node silicon and a user experience paradigm change, a big, beautiful display that was inside the Tesla Model S. Then we have open application developer ecosystems. Infrastructure came last year with the commitment of Tesla to open their charging networks and a bunch of other OEMs banding together to build their own supercharger network. But what about that fifth and final element that's going to radically change this industry, that market disruption? And for those of us here in the US, we're probably not seeing it because it's happening in a lot of other countries around the world. New electric vehicle entrants from China and Southeast Asia are building cars based around a battery and a computer. And they're doing so in an IT-like 12 to 18-month design life cycle compared to the traditional 4 to 5 years that we have in the automotive industry. They're delivering leading node experiences that are resonating with today's consumers who are millennials and Gen Zers, who grew up with tablets in their face and smartphones in their pocket. And so they expect their car to be the same, leading node, advanced experiences, an extension of their digital self. So this last market element is now coming into place. And so this is why we at Intel believe that the industry pivot for automotive is now, and that decade that we've spent talking about a transformation to a new kind of automotive future is finally going to happen. So if that's not enough to convince you, check out the stats there on the right. In a 10-year period, smartphones went from about 20% of the market to about 80% of the market. We project software-defined and electric vehicles to follow almost exactly the same trajectory, from about 20 to 80% of the market. And this is why for companies like Intel, we believe not only is there opportunity, but there is a reason for us to help. So we believe the pivot is now, and we are here to help. So just as feature phones went from analog to digital, fixed function to software-defined, and lagging node to leading node, we expect the same thing to happen in vehicles. But current vehicle architectures are based on a decades-old embedded microcontroller architecture that has really just organically grown, but was really never designed as we would from scratch today. So here, the architectural challenge to the industry is clear. We need to move to a software-defined architecture, and here Intel can help. But the future must also be sustainable. But we're on the precipice of a sustainability crisis in the automotive industry, with demand for raw materials far exceeding supply needs around the world. But here as well, Intel can help. And finally, the future must be scalable. And so what do I mean by this? Automakers can't afford to have different microarchitectures in their vehicle lineup across their products. They need something that's flexible, that's scalable from the luxury vehicle all the way down to the segment vehicle with compatible software top to bottom. Here as well, Intel can help. So let us take a closer look at each of these pillars and see what we are doing. So first up, the software-defined vehicle. We've been reading about this for a long time, it feels like. But I think there's an important distinction. It's one thing to put software defined as a label, and there's another thing to actually be doing it right. And as we'll talk about, there's a significant difference in software defined done right versus using it simply as a label. But let's look at our starting point. So the picture here on the left, this is a car that most of us drive today. It's that architecture that's based on dozens and dozens of microcontrollers. It's a natural evolution of a 50-year-old architecture where each feature is a new electronic control unit. So as each new feature was developed, a new box would be added. And these are fixed function. They're not upgradable. And in many cases, the teams that originally built them are long gone. And so if something breaks or you need to update it, you might not even be able to do so. And they're connected together with over a mile of copper cabling. And that's fine when the price of copper was 66 cents a pound, as it was in the year 2000. But when it hit over $5 a pound 2 years ago, that becomes a serious problem. So it's too costly, it's inflexible, and it's not sustainable economically or technically. So what we need to do is move to the picture here on the right. And for those of us in the IT industry, this looks like a data center rack. You've got an Ethernet backplane, high-performance compute socket, and total cost of ownership is what matters. Managing performance, cost, flexibility. And ironically, Intel, we made this transition as well decades ago. First data centers were simply high-end PCs, and each box ran, say, a website or some internet application, right? Then we realized that wasn't scalable, so we created hardware technologies like virtualization and put them into our silicon so you could run multiple different operating systems at the same time on a single piece of silicon. So that same opportunity exists for us in the automotive industry to consolidate workloads into a software-defined architecture. So we continued that with a software ecosystem, with hypervisors, application container frameworks, orchestration layers. But in the automotive industry, we've got a legacy of real-time operating system code that's running on embedded microcontrollers. What the industry needs is a new path that combines the best of both, that allows the industry to preserve your legacy software investment, supported by silicon-enforced separation for mixed criticality workloads, while you can embrace the new, embrace Linux, embrace Android, embrace open application frameworks in a way that can all be supported on a single silicon platform. So this is why we believe that a silicon foundation in the origins of the data center is required to do software-defined done right. So with that context, I am very proud to announce today the first generation family of SoCs specifically designed for the software-defined vehicle. Combining the best of the AI PC and Intel's rich technology portfolio from the data center, these products provide not just the power and performance scalability that automakers require, but AI capabilities for differentiated experiences inside the vehicle and silicon-enforced separation to combine multiple workload and operating environments at the same time. These products will be shipping in high volume by the end of this year. And right after this session next door, you will be able to see it live in person and see a real demonstration of the new kinds of vehicle experiences possible with these products. So here's a teaser of what you'll see. All right, pretty cool, right? Hey, Pat. Pat Gelsinger, everyone. Check this out. Thank you so much for being with us here today, Pat.
Well, thank you. It's delightful to have the opportunity to come and join Jack, but to come and talk about what we're excited about
Yes.
in the automotive sector. You know, I'm a certified geek, but I'm not really a car guy. I'm more of a tractor
Tractor, I
guy.
think, yeah.
You know, growing up as a farm boy. But you know, as we look across every aspect of humanity, everything's going more digital, and that's very much the case with the car industry as well.
You know, I can't. Everything in my life is digital now. You just can't escape it. Everything in our homes, and especially our vehicles, are being transformed by this digital economy. So I think there's never been a better time to be a geek in automotive than right now.
Well, you know, and you know, everything about the car, as we think about this digital transformation, it needs more compute,
Yep.
it needs faster memory. You know, we have to become more power performance efficient. You know, and every aspect of it is becoming more silicon centric.
Yep.
And you know, this you know, transition, and as you quote my mentor Andy Grove, you know, it's in a period of disruption. And you know, I decided when I came back to Intel to take Mobileye public and to really take that opportunity at scale. But I also was pretty excited to get your business up and running and healthy as well, Jack.
Yeah, absolutely, Pat. You know, but I've got to ask you a question that I think is on the mind of many people in this audience. So how can this industry really trust that Intel is committed to automotive?
Well, and you know, as I came back to the company, this was you know, clearly one of the questions that we had to address. And as I came back in 21, how many times were we in and out of the automotive industry?
Yeah.
You know, but as I came back to the company as well, we were also in the middle of the COVID crisis, right? And all of a sudden, our phone is ringing off the hook, right? You know, from the automotive companies as well. How can you help us? You know, and as we study this sector, you know, we also realize the explosive growth. And today, the BOM of the car, 4 or 5% silicon, and it's you know, by 2025, 12%, and by 2030. 20%. So a 4 or
amazing.
5x increase in the silicon components. So one, it's a good market for us as well. We have this lead pin with Mobileye. You know, we're getting into the foundry business, and we'll touch on that as well. So we see that. So it was really 1, 2, 3 great reasons for us to commit in a fundamental way that we're in for the long term in this sector.
Well, as a car geek as an Intel and as a chip head, this sounds awesome. So it sounds like what you're saying is our customers can count on us to be here in this industry, not just today, but for decades to come.
Yeah, and you know, very much so as the auto industry, the you know, commitments that they make are for platforms that are 1, 2 decades long. We have to be in it long term. You know, this whole COVID cycle, you know, this ability that we have as a, you know, both a design and the product company, but as a manufacturer at scale, that we can make those commitments that are multi-decades long, that, you know, we have the products, the capacity to do that. And as we've rolled out the IDM 2.0 strategy, we said we're not only going to manufacture Intel's products, we're going to become a manufacturer for the industry at scale. And with that, you know, I've rolled out, in the 5 years before I became CEO, Intel invested $50 billion in capital. The 5-year plan that I laid out to the board of directors was $150 billion in capital. And I said, and it may get bigger. Right? I mean, it's an extraordinary amount of capital. So our ability to make these commitments of major manufacturing in the US and in Europe, those long-term secure supply chains that the customers need across different industries, but very much so in the automotive sector. All of that's what leading us to make these long-term massive commitments. And I need customers that are long-term and large.
I'm going to bring them for you. Well, thank you, Pat. I mean, I think it's amazing how Intel's IDM 2.0 strategy is really a perfect match, it feels like, for what the automotive industry needs. And I think Intel is here not just to help this industry survive, but thrive during this incredible time of transformation.
And, you know, as we think about this period of transformation, you know, what do you need? You know, is the autonomous going to require more performance?
Yep.
You know, is the electrification going to require more performance?
Yep.
Is the in-vehicle infotainment going to require, you know, all of this is performance, performance per watt, sustainability, and these next generation products, all of those are what we do, right? You know, this is the heart and soul of what it is. And we've learned in bringing many of our experiences from, you know, the PC industry and what that means, but also now this whole electrification and what we've done with the laptop and getting very power efficient. And the car is essentially a laptop with, you know, tires and an engine. And, you know, and this is, you know, this expensive, heavy part of the EV, you know, needs new technology approaches as well. So can we do something there?
I think we should, Pat.
And with that, Jack, you know, we're just to reinforce the commitment that we have to the industry, we're very happy today to announce that we've reached an agreement with Silicon Mobility, and of course, all the legal caveats. We got to pass regulatory and all that other kind of stuff, right? You know, do you feel legally safe now? Yeah, okay, yeah. But we're going to acquire Silicon Mobility, and we're going to bring their energy management solutions at scale. You know, we've seen extraordinary benefits that they bring to the energy efficiency of EVs and AV, EV, and, you know, the software-defined, you know, and this complements our technologies extremely well, and new opportunities for us to intelligently manage, right, you know, this critical resource, right? You know, the electrification of the vehicle.
That's awesome, Pat. Well, thank you, Pat, for this incredible, I gotta say.
I'm counting on you, Jack.
I'll do it. I think this is an amazing announcement for us today. You know, but what I love about this is it shows not only our commitment to this industry and that we are willing to invest, but that we're taking a holistic approach to solving the industry's biggest challenges. You know, think about the unique combination that our high-performance AI-enabled SDV SoCs could bring in terms of bringing more intelligent power and energy management across the entire vehicle platform. This acquisition will expand our product portfolio from high-end performance AI-enhanced SoCs all the way down to low-power microcontrollers and beyond. So the innovations that this team at Silicon Mobility will bring to Intel is going to pay dividends, I think, for decades to come.
Well, I'm counting on it.
Deal.
Well, you know, and, you know, with that, I guess the pedal to the metal, Jack, as we're going to bring this business forward. We'll get the regulatory approvals done, you know, scale this, you know, elegant technology with a powerhouse company at scale like Intel behind it. But, you know, this is only part of what we're doing, Jack, as well. And maybe we can actually talk to a software-defined vehicle customer.
Let's do it. I love it.
Yeah, so let's bring Andy on, President of Geely Holding Group, CEO of Zeekr Intelligent Technologies, and let's have Andy join us on stage.
Hi. 你好吗？
Well, Andy, thank you so much for joining us. I am so thrilled the partnership that we have with Mobileye and Zeekr, the Intel Zeekr and Geely partnership, and we're adding to that today, Jack.
Yes, we are. So, Andy, can you tell us a little about your perspective on what we're talking about today?
Okay. I'm very happy to be here. I'm also very honored to share an exciting news with the audience here. The Intel is co-creating the next generation smart electric vehicles experiences with Zeekr. I think that this system would bring a very revolutionary upgrade of the infotainment experiences that we can offer to the customers.
Well, you know, and you know, we're so excited to both have you here, but to also hear, you know, about the incredible innovation and how, you know, AI is just the story here at CES, and the dramatic productivity and economic booms and the innovation that you're bringing to the car industry. And having visited your factories and the cars, right? You know, it is, you know, truly a good car. So I am just thrilled.
Cars are not just tools for the transportation. It's not just hardware. It's not just mechanical parts. They are not enough for the very good user experiences. cars are entering, or the auto industry is entering the era of software-defined vehicles. The software are defining the vehicles in the future, and we are already in this era.
Yeah, Pat, it's interesting. I'm reminded you talked about your mentor and former CEO, Andy Grove. And he used to call the PC the greatest Darwinian device ever, meaning its propensity to evolve, adapt, and change, and deliver new experiences that would become more advanced and more personal. So I wonder, what do you have thought of an AI PC in a car?
Well, I think, first, Andy would have said the AI PC, get on with it, Pat, right? Make it happen, right? And this transformative experience, because the PC has been changing dramatically. And as I've called it, the Centrino-like moment, right, that ushered in laptops and Wi-Fi. But now the idea of bringing the AI PC into the automobile proper, and I can't wait to see what those in-vehicle experiences are going to be. So what are your thoughts, Andy?
I think based on the very advanced AI and the large language model developed by Intel, we can bring a very good innovation and full of imaginations applications of the mobile living.
Thank you, Andy. I mean, I could not have asked for a better launch partner for our brand new AI-enhanced software-defined vehicle SoCs than Zeekr. So please put me on the waiting list. I'd love to order one.
Very good.
Thank you for your support and your commitment. Pat, thank you for your support and
thank you
commitment
so much,
to
Jack.
automotive.
Okay.
Thank you, Andy.
Okay.
Thank you both.
Very good.
Andy and Pat, everyone, thank you. All right, so pretty cool, right? We are just getting started. So let's talk a little bit more about the sustainability challenge that the industry is facing, because I think there is something more that Intel can do to help. I read an article recently that said an EV's battery makes up about 30 to 40% of the cost of the vehicle and 25% of its weight. And batteries keep getting bigger and bigger. So this is simply unsustainable, and something has got to change. But there's a problem even bigger than that, which is where will these raw materials come from? McKinsey estimates a 55% gap in demand versus supply for lithium carbonate. Another analysis showed that by 2050, the demand versus supply gap for cobalt could be 80%. And as I mentioned, battery packs are getting bigger and bigger. The average size of a battery today is 80 kilowatt hours. Just a few years ago, it was half that. And there are cars on the road with batteries that are 200 kilowatt hours in size. They're too big, too heavy, or too expensive. And so this trend is simply unsustainable. But there is something that we can do. We could hope and pray for a breakthrough in battery technology. Maybe that'll happen. Or we can focus on the efficiency side of the equation. And this is something where, again, the industry can learn from where Intel has been before. So who had laptops like those there on the left? Remember? Weighed about 20 pounds. 2 hours, I think, is generous on the battery life. Those first-generation laptops were desktop PC boards laid on their side with a battery attached, okay? Meaning everything about that PC platform was designed to be plugged into the wall, a source of nearly limitless energy. So there was no point in trying to conserve energy when you were plugged into the wall. Okay, so when you suddenly took that platform and made it mobile and had its energy now come from a battery, a constrained energy source, that's why you saw laptops with terrible battery life in the early days. So in this time where desktops were king, this is what it was like, to be in the mobile industry. So the same is true for most electric vehicle platforms today. The vehicle platform, think about all those embedded microcontrollers, all those boxes and all that cabling, that was designed to run behind an internal combustion engine. An energy source that at idle has so much energy to go around, again, there's no point, there's no purpose in trying to think about, well, do I need to be powering all this stuff right now? Because it doesn't matter. You've got plenty of energy coming from the engine, just like you had plenty of energy coming from the wall. But as electric vehicles are now where the motor itself is a semiconductor device, and you have all those other microcontrollers and semiconductor devices. As Pat said, 4 to 20% of the vehicle's BOM is now going to be semiconductors. All of that energy consumption starts to add up, And all of that energy consumption is contributing to these incredibly large and costly batteries. So what did we do to solve this problem in the PC industry? So what we did is we led the creation of an open industry standard to benefit all PC makers. It was a standard called ACPI, Advanced Configuration Power Interface. And what it defined is system states for the whole platform. Is the PC on? Is it off? Is it in standby? Hibernate. Remember all those power modes? And then for each of the subsystems within the PC, so this could be your audio subsystem, your display subsystem, we further define the ability to set and control power states. And then within each of those subsystems, you might be able to refine even further the amount of energy consumption. So you can optimize and tune the platform to maximize energy life. And so in doing this, by reducing a processor's frequency by 15% in some of those early platforms, we were able to reduce the power consumption by 50% because of the power scalability curve. And so these simple mechanisms we think could apply just as well to an electric vehicle. So for a whole electric vehicle, is it on? Is it charging? Is it idle? Is it stopped? You know, is it on the freeway, urban, other? There's lots of concepts we could apply for the overall system state. But then each of those ECUs, if I'm charging my electric vehicle, why is my ADAS ECU powered right now? If it's summer in Arizona, why is the seat heater ECU powered? Or winter in Detroit, why is my air conditioner powered? Today, all of these electronic control units run at full power all the time in a traditional vehicle platform. So what about if there's no passengers in the rear cabin? Why are those displays turned on? So the possibilities to save and conserve energy and make more efficient use of the limited resource that we have are really limitless. And these concepts are proven in use, you know, in the PC industry for over 20 years. And we believe if we do this together as an industry, we could save we could have a 30 to 40% energy efficiency gain with an optimized vehicle platform. So imagine a 30% smaller battery, or the same size battery and 30% more range, right? So all of these possibilities are possible if we simply look at energy management more intelligently and from a whole vehicle platform perspective. So with that, please join me in providing a very warm welcome to Christian Thiele from SAE International to learn what we're going to do about this problem. Christian. How are you?
Hey, Jack, doing great.
Good
to see you.
Fantastic to be here. So what do you think about this crazy idea, applying IT concepts to an automobile?
All I can say, Jack, is this is a fantastic idea. I think it's very important, obviously, from effectivity and efficiency point of view that is necessary for the EVs and all electric platforms.
I'm glad to hear that. But, you know, a car is not a PC, right? So what advice do you have for us there?
Sure, you're absolutely correct. At the end of the day, we recognize and we understand the challenges of the PC that you guys, obviously over 20 years, developed to make it more efficient. Obviously, a vehicle is dependent on that battery power. And the more efficiency we can drive into that, the better off we are. And obviously, by power management type applications, that will be greatly beneficial.
Yeah, but in a car, we've got completely different networking buses.
Yep.
We've got lots of different kinds of semiconductors from small to big. It's a very different platform architecture. So it sounds like an opportunity where we need the industry to come together and figure out how we can take these proven and used concepts, but adapt, tune, and customize them for the automotive industry. It sounds like a perfect activity for the SAE, doesn't it?
Yeah, this is an absolute fantastic activity for SAE International. SAE International, as you know, we've been around for 118 years developing standards. And right now, in this ambitious time and with the emerging technology space, the electric vehicle space, the AI space, the automated space, it is vitally important for industry as well as academia and government to get together to help drive these efficiencies and make these vehicles more sustainable. And this power management system, with the new standard that we're out there now with the J3311, which we are now calling to action to bring in those subject matter experts to help us and support us to drive industry to develop this to make these vehicles more effective and efficient.
Well, thank you, Christian. So yeah, good news, right? I can't think of a better place than the SAE to do this. And on the behalf of the companies behind us who have all committed to join this work group, we look forward to bringing these proven and used concepts to the automotive industry and doing what we can to help. So Christian, thank you very
Jack,
much.
always a pleasure. Thanks
Thank
so
you.
much.
Take care.
Thank you.
All right, so there's one final challenge that we haven't talked about. We solved the architecture challenge. We talked about electric vehicles, battery sustainability. But what about that scalability challenge? Okay, for automakers, they really struggle. There's no single solution that scales top to bottom across their vehicle lineup. They might choose a really nice high-end solution that's not going to scale low, and a low-end solution won't scale high. And so what do? Well, you could have multiple different solutions, but that means automakers are having multiple different duplicative software teams, which massively increase the level of investment. So that doesn't work. The industry needs an alternative. And so to understand the origins of the solution, let's go back to the ITE industry again. So for decades, we would build single monolithic semiconductors. Okay? And within that die, we could fuse it and offer a couple different SKUs for high, medium, and low sort of performance, and we'd price it accordingly based on the features and performance that you'd get. And that works when the range of performance that you're looking for falls within a narrow enough band, okay? But it doesn't work when the range of performance that you need is more like an automaker, from a luxury vehicle all the way down to a value segment vehicle. So what would an automaker do? Well, they could buy or source, as I said, multiple different monolithic designs. A semiconductor supplier could themselves design multiple different monolithic designs, but that just gets too expensive and costly and prohibitive. And worse, even if I'm going to make a high-end and low-end part, how do I know I picked the right scaling factor for the different functions? What if one automaker would have preferred a little bit more GPU instead of CPU? What if a different automaker had exactly the opposite needs? And so it's really difficult to predict and guess right and satisfy the needs of the flexibility and scalability that the industry desires. Monolithic solutions further have a disadvantage in that they can only put into that single die what that node is capable of. So if there's no support for embedded memory, or if there's no support for analog logic, there's no solution. You can't build it. So at Intel, years ago, we committed to a disaggregated architecture where we divide our SoCs into different chiplets, where each chiplet can independently scale up or down from each other, and we can pick the right technology node for the function in the chiplet. And so the result is our customers today have much more flexibility and choice on the specific configuration that they're selecting. And in doing so, they're able to optimize cost, power, and performance. So I'm thrilled to announce then that Intel is taking this innovation that we have done in the PC industry and we are bringing it to automotive. We are committing here today to be the first supplier to deliver an automotive-grade chiplet-based product to the automotive industry. Thank you. We believe this is the right approach that will allow the industry the opportunity to flexibly scale as they need across their vehicle lineups. And we are further disclosing that we are partnering with IMEC to ensure that our advanced 3D packaging technology fully meets and complies with automotive industry quality and reliability requirements. IMEC brings over 40 years of rich history and expertise in semiconductor innovation, and we look forward to working together with IMEC, and we look forward to all of you hearing from IMEC that they agree and have helped us make our packaging technology meet the automotive industry requirements. But we are not stopping there. We're going to take it one step further. We are going to offer our customers the opportunity to integrate their own chiplet into our automotive roadmap products. Thank you. By utilizing the UCIe standard that Intel has created, automakers can now select, bring their own IP into our products. They can do so on any node, manufactured anywhere, and our Intel Systems Foundry capability can integrate that together, test it, validate it, and deliver it back to the automaker as a finished hybrid custom product. So the differentiation possibilities here we think are really endless. And this allows automakers to have all the benefits of a fully custom design at a fraction of the cost. So we are thrilled to be not only the first automaker supplier to commit to a chiplet-based design at automotive grade, but to do so in an open fashion that can create an ecosystem of chiplet providers and opportunities for automakers to create and embed their own IP into our products. So we think the possibilities are endless, and we can't wait to see what kinds of chiplets you'll bring to us. So we're on a roll. We've covered a lot today. We've charted out a path to bring the AI PC to the car, blended with our rich history of data center technologies to support software-defined done right. Pat announced our agreement to acquire Silicon Mobility and bring their incredible energy efficiency improvements to electric vehicles that, when combined with the intelligence in our software-defined vehicle products, will bring opportunities for incredible advancements and intelligence in power and energy management within electric vehicles. We also announced with SAE a game-changing industry standard that takes proven and used concepts from the IT industry, and we're going to apply and morph and adapt those for the automotive industry, for the whole industry to benefit from. And finally, we announced the world's first open chiplet architecture to enable our customers to bring their chiplets into our product. So I'm biased, obviously. I think this is pretty cool. But one more reflection. I think this changes, I hope, your view of who Intel is. This diversifies our ability to partner and supply you with not just high-performance SoCs, but anything at any of the major layers of the automobile, whether it be power delivery, networking, compute, software-defined, AI-based experiences. We are committed to being a diversified supplier to the automotive industry and co-designing these elements together to bring the industry incredible opportunities for innovation, efficiency, and cost improvements. So let's hear what an independent voice would think about all this, so you don't just have to believe me. So I am truly honored to welcome to the stage Junko Yoshida, former editor-in-chief of EE Times and founder of the Ojo Yoshida Report. Hi, Junko. Great to see you.
Oh my God! I haven't seen you for
I
like
know,
2 years.
it's great. It's nice to see you.
Last time I saw you were playing the piano.
It was, that's right.
Yeah.
That's a long story.
Okay, great. Well, thanks for the invitation.
No, my pleasure. So you've been out on your own now a couple years. And so for those that aren't reading the Ojo Yoshida Report, you are missing out on a fantastic source of fierce independent journalism for the automotive industry. But how's it been? You're at a startup now, essentially, right?
It is hard. Startup is really hard to make money, but at the same time, we are having the, life of a time. Really, it's no string attached.
Yeah.
We get to write what's important, not just what's important for this particular company, but what's important for the rest of the industry, and what questions we need to ask. The more technology come into our world, I can't just take your word for it. I need to verify other people are saying same thing, or other people have valid arguments, right? And we're here to help that arguments.
Okay, so be brutally honest with this audience here.
Yeah.
What do you think of our proposal for a more software-defined, scalable, and sustainable future for automotive?
The first time when you approached me,
Yeah.
I said, oh my God, I really want to come here because I don't want to cover teraflops, AV, EV, ADAS or whatever the new thing is, because that's been already covered. And a lot of people are doing a really great job, but I'm more interested in what, okay, we can put technology into the car, but we can't really solve the safety problem unless you actually look at the whole car. So I really like the software-defined vehicle idea because that's really critical. But my best favorite is the power management for the entire car. We write about the silicon carbide, GaN and all that, and that's all important. But at the same time, I'm so glad Intel came out looking at the entire car.
Yeah. Well, thank you for saying that. You know, as Pat said, when we spun Mobileye out, it created an opportunity for us to look at the whole industry
Yeah.
and look at the whole vehicle.
Yeah.
And we realized not only our new corporate strategy, our IDM 2.0 strategy, but also our assets, our strength, and our experience was actually a wonderful fit for the challenges the automotive industry is facing across the entire vehicle platform.
Yeah.
So,
But, you know, let me ask you this. As a reporter, I kind of glam onto the really easy marketing jargon, well, not jargon, marketing label, as you said. One is that smartphone on wheels, servers on wheels, data centers on wheels, digital living room on wheels, digital office on wheels. So what is it really?
it's a great question. I think it's actually a combination of the above. And I think that's maybe part of the challenge in the industry, why we haven't quite zeroed in on what's the right thing, because you need a mix of all of the above. You need AI capabilities for differentiated experiences. You need a pedigree of data center virtualization technologies to do software-defined done right. And you need the energy efficiency innovations that have been pioneered in the PC industry as well. And combining all those together, we think is finally the right approach. So we'll have to think of some cool marketing label, but
I know.
maybe you can help us with that.
But, you know, the one last question.
Sure.
Though. Why did it take so long for Intel to come up with Intel's automotive strategy? I mean, Intel is a huge company. It's got all the technology ingredients, right?
Yeah.
Why 2024?
Better late than never, right? so thank you, Junko. I mean, I really appreciate your feedback. I'd love to keep talking, but we're keeping this great audience from free drinks and demos next door. So for our own personal safety, we should probably close here.
Thank you so much.
Thank you, Junko,
good
so
luck.
much.
Well,
I appreciate it.
I'm watching you for the next 20 years.
You can do so. Thank
All
you.
right.
Take
Thanks.
care. Thank you, Junko. All right, so I'd like to extend a sincere thank you to our special guests, Pat, Andy, Christian, and Junko for joining me today. So I started off by saying we are truly at an existential moment in the automotive industry where this industry is going to look completely different by the end of the decade as it does today. And as you heard from Pat, Intel is making significant investments to better serve this industry. We believe we have the right experience, the right expertise, and the right commitment to help this industry not just survive but thrive for the next century. So our vision for a software-defined, sustainable, and scalable vehicle is real, it's feasible, and we are ready for your input, your feedback, your collaboration, and your partnership. So with that, I'd like to welcome you to the Intel Tech Showcase, located immediately next door. And as a teaser, we have one more special guest.
Do you think you know all there is to Intel Automotive? Test your knowledge with me, Ken Jennings.
All right. I said the geek was back, so we've got Ken Jennings next door for you to see right next to our demo. So please go check it out. Thank you for being such a great audience. We'll see you next year.